Okay. We've been doing all kinds of great stuff with rational functions. We've been simplifying them, add, subtract, multiply, and divide them. And now it is time to wrap things up with graphing them. And so we're going to get real used to this idea of asymptotes, and I think we're already kind of like acclimated towards it. But let's see how these things work and how we put all the pieces together so we can graph these guys. Okay, and so how basically what we're going to learn to answer these questions: how do I determine horizontal and vertical asymptotes? How to use polynomial division to determine an asymptote? What is a parent form of a rational function? And how do I use functions to solve problems? And this next part right here, I'm only going to refer back to when we get to those parts. But remember, this is all about determining the asymptotes of a rational function. And we're going to, again, go over that when the time comes up. And we'll see how this all plays out. Okay, so first things first is that we need to go ahead and take a look at how to go ahead and graph these using a shift format. So the first thing that we want to go ahead and do is that we want to realize that when I have this type of format right here, is that this guy right here is going to be our multiplier, and this part right here, the H, means is that we're going to shift the entire graph left to right in the opposite direction. And this means that we're going to shift the entire graph up and down in the true direction. Okay, and we've seen those before. So let's take a look at what we're up against. First thing that we want to do is that we want to take a look at the parent function of the basically, which is going to be 1 over x. And as you remember, okay, from either class or Math 3, is that some of these guys, this is going to be the parent function coming through here, and we have asymptotes that are going to go ahead and be at the x-axis and the y-axis. Okay. So why those are going to be covered in a different video. This is just basically how do I graph these particular functions. Now, what we want to do is that we want to really kind of key in on these nice points right here. Okay, and we want to make sure that we are also understand this business of the x and y asymptotes that are kind of going to go ahead and be like this and like this, kind of like creating like that bullseye mark, if you will, in the middle. So this is where we start. So the next thing that we're going to go ahead and do after this starting graph, and by the way, these points, and then I'm going to just show them real quick and then erase them out, and then we'll go from there so we have exact points to go ahead and play around with. Okay, so these are the points, the actual points that that we're referring to right here, here, here. And just to go ahead and start your graph off, and the asymptote is going to go ahead and be right on the x-axis, so that's going to give us a y equals 0, and this asymptote is going to be x equals 0. So that's where we start off. Okay, now I'm going to erase these out, and from here we're going to go ahead and just take the points and the asymptotes and shift them around so we can go ahead and create a new graph. Okay, so the next thing we got to do is consider the multiplier. Now, the multiplier is not going to change our graph this time at all, because we notice that the multiplier is 1. And when we have a multiplier of 1 that we found out in the past, that it doesn't change the graph whatsoever. So the graph is going to stay the same until we shift it. And we're going to be shifting using these guys right here and these guys right here. Okay, and so, actually, let me put these in a different color so it makes more sense. Okay, so using this and this right here. So basically the shift, when I put everything together, I'm going to be doing this, and I'm going in the opposite direction of that. So that means I'm going right 4 and in the true direction of that guy, and then up 3. Okay, so let's see how this plays out. Okay, so when I go ahead and I shift everything right 4 and up 3, that includes the asymptotes. And so basically I'm taking the entire graph as is and I'm shifting it. Okay, and I'm going to try, oops, I'm not going to do that. See if I can do this in real time here. And I'm just moving the graph using some digital magic here. And so basically it's going to go 1, 2, 3, 4 to the right and up 1, 2, 3. So you see that the entire graph has moved. Okay? And really, what we're looking at is in the middle here, you want to make sure that this is going to be like, in this case, 4, 3, right in the middle for these asymptotes where they touch. Simply because that's basically how you're moving the graph. If you were to grab the graph in one particular spot and move it around, that would be it. Okay? And so therefore, looking at extending these asymptotes out, and extending the graph a little bit. Oops, that is not the one I wanted. In this direction, we end up with our new looking graph here. Okay? So, what we have to do is that we have to look at our graph and then start filling in some information. So let's start with the asymptotes. The vertical asymptote, since it's moved 4 to the right, is going to go ahead and be x equals 4. Okay? And the y asymptote, since it has moved 3 up, it's going to be y equals 3. Okay? Now, from here we have the x-intercepts, and I can do these out below, is that for the x-intercept, we know that we are going to be letting y equals 0. So that basically means is that I'm letting f of x equal to 0 here, and now I can set this up and solve. So, as a review to go ahead and solve, and I don't know what this blue mark is right here. I couldn't get it off the computer, so I'm just going to sidestep it here. Is that I'm going to subtract 3 from each side. Okay. And now I have an instance where I can go ahead and cross multiply this way and then solve for x. So I end up with a negative 3 times x minus 4 equals 1 times 1, which is 1. Distributive property. And now I got this. Okay. And I'm going to subtract 12 from each side, and that's going to give me a negative 3x equals a negative 11. And then divide by 3, so x equals 11 over, oops, not 2, 3. And so I know that that is going to go ahead and be in other terms about what? 3 and 2/3. And so, if I look at where the x-intercept is at, does it seem to be about 3 and 2/3? So I look over here, and I'm making a bigger dot right there. That seems reasonable, because we got like 1, 2, 3, and then 2/3 there. So it looks like we are in the vicinity here, which looks good according to our graph. And so our x-intercept is going to be 11 over 3, 0. Now, the y-intercept is going to be some pretty straightforward stuff. Okay? And the y-intercept is going to be just plugging in 0. So if I go f of 0, that means is that I would have this right here. Okay? And so the way that I look at that is that's going to be like a negative 1/4. And so if I add a negative 1/4, 3, that is going to give me 2.75, or if we're going to keep it in fractional form, let's go ahead and say, 11 over 4? Right. Getting some common denominators there. So I hope we're good with fractions here. And so 0, 11 over 4. And again, we had mentioned that is going to be about 2 3/4. And so, does this look about 2 3/4 right here for my x-intercept? And the answer is yeah, that looks reasonable. Okay. Now, we don't need any strategic points at this moment. That comes in some later problems. But yeah, that's how we go ahead and we shift around something that has a multiplier. And it starts off in standard form. And we're about to go ahead and take a look at something that has an actual multiplier that's going to modify the graph. And so, yeah, let's see how that works. So, on to the next one.